Greetings. Thank you for joining us today for EarthEcho's STEMExplore Virtual Career Connection, featuring Dr. Jamie DeWitt, Associate Professor of Pharmacology and Toxicology at East Carolina University, and also featuring Dr. Theresa Guillette, Postdoctoral Research Scholar of Biological Sciences at North Carolina State University. Jamie and Theresa are environmental toxicologists, and these are scientists who try to understand how living organisms are affected by pollution. We're so excited to have them both here with us for this tremendous virtual career connection to tell us about their work. My name is Casey. I'm a programs manager here at EarthEcho International, and we are joined today by one of our exceptional Youth Leadership Council members, Haley, and she's going to help me moderate today's live event. Here at EarthEcho, we're proud to work with an outstanding group of young leaders who help drive our work to empower their peers around the globe to take an active role in protecting our planet. And Haley is a great example of that. Haley is a science student at the University of Melbourne, Australia, here where she is hoping to major in ecology and evolutionary biology. Possibly toxicology too, I just learned. She also has a side focus of zoology and environmental politics and management. Recently, her environmental conservation efforts were recognized in 2017 for the Margaret Andrews Memorial Prize for Leadership and Citizenship. So welcome, Haley. Go ahead and take it away.
Thanks, Casey. We are so excited to have students from all over the globe joining us as we learn about exciting and sustainable careers in science, technology, engineering, and maths, or STEM. This live event is part of STEMExplore, EarthEcho's program that brings inspiration to life by telling the stories of dynamic female professionals in STEM careers during live virtual career connections. We want to thank our founding sponsor, United Technologies, for their support of women in STEM. Here at EarthEcho, we believe that youth have the power to change the planet. Visit earthecho.org to learn more about our programs. You can also access resources like STEMExplore's career profile videos, as well as tune in for upcoming events just like this one. I'd like to recognize and thank STEMExplore's partner sites across the country and recognize those that are joining us today. First, let's get a hello from the New Old Clubhouse at the Boys and Girls Club of Santa Clarita Valley in California. Hi, everyone. And let's also head across the country to Charlotte, North Carolina to say hello to our partners at MECED. Hi, MECED.
Hello. Hello.
We also have sites joining our live stream, and welcome to everyone tuning in. Just a reminder that you can send in questions for our STEM experts via chat, and we will break throughout today's presentation to see if you have any questions. Feel free to start typing questions in the chat space on any of our live feeds. We'll be sure to answer those as we go along. Now let's get started. I want to firstly welcome our special guests for EarthEcho STEMExplore Virtual Career Connection, or multiples, Dr. Jamie DeWitt and Theresa Guillette. Thank you for joining us, ladies.
Thank you for having us.
Oh, sorry. First, let's introduce Dr. Jamie DeWitt. Dr. DeWitt's research program explores relationships between biological organisms and their responses after exposure to environmental contaminants. She is interested in how early life exposure to a variety of agents may impact the immune, nervous, and endocrine systems, resulting in altered development that may present as a disease or a disorder in childhood or later in life, as well as responses of adult organisms following exposure to environmental contaminants. Dr. DeWitt focuses much of her attention on emerging environmental contaminants, especially compounds known as per- and polyfluoroalkyl substances, or PFASs. Jamie, why don't you tell us more about yourself and what you do?
I am absolutely delighted to be here. So hello, everybody who's listening. When I first sort of entered the working world, it was as a very young child. I had my very first paid modeling experience when I was about 3 years old, as you can see from the picture on the far left. And I did at one point have some hopes of becoming a model, but as I grew and developed into an awkward teenager, I realized that maybe I should focus my time and attention elsewhere. I was one of those kids who completely dug horses. And so I managed to get a job at a horse farm working with standard bred horses. And I thought, I want to be a vet. I love animals. I love horses. I lived in a rural area. There weren't a lot of other people doing science around me. Nobody in my family had gone to college. So I thought, all right, I'm going to go to college and I'm going to become a veterinarian. And so I went to college. I did all my applications on my own. I did all my financial aid applications on my own. And so when I went to Michigan State University, I was kind of terrified because I was this small little country girl in this really big school. Fortunately, I got a really cool job at the museum and learned about mammalogy, which is the study of mammals. It was in our zoology department, and started learning a lot more about the different types of science that people could do. And I eventually got a job working in a lab in entomology where I got to dissect ticks. That's why there's a picture of ticks. And loved kind of looking at the guts of ticks and figuring out what sorts of little microorganisms lived in the guts of ticks. After I finished my bachelor's degrees, I got a job working at the health and safety office at the university's campus at Michigan State, because after I graduated, I really didn't know what I wanted to do. I'm not one of those people who has this glorious 5-year plan and I was going to do A, B, and C. Once I got to college and realized that veterinary medicine wasn't for me, I kind of flitted and floated from major to major, finally ended up studying environmental science and biology. But when I got this job in environmental health and safety, I learned about this area called toxicology, and learned that toxicology brings together environmental law, economics, biology, chemistry, public policy, public health, all the things that I really liked and was interested in. And so for me, toxicology became the perfect science for me. After I sort of understood what toxicology was, I applied to environmental science programs, and I ultimately went to Indiana University and got a PhD in environmental science with a focus on neurodevelopmental toxicology. In other words, I looked at how environmental contaminants affected the brain. After I learned a little bit more about toxicology, I took some courses in neuroscience and got an additional PhD in neuroscience. Went on to do a postdoc at the EPA, and now I'm here at ECU and am studying aquatic contaminants and how they affect different organisms. So that was a very long introduction, but that's how I got to be a toxicologist. And so in toxicology, we ask questions about what chemicals in the environment, or at least in my lab, I ask questions about what chemicals in the environment do to the body. And I focus specifically on what these chemicals do to the immune system, and to a lesser degree, what these chemicals do to the brain. And some of the questions we ask about the immune system are questions of how the immune system functions. So one of the questions we ask is, can organisms respond to a vaccine? So when people go out and get flu shots and also are exposed to chemicals, are they going to be protected against the flu? Is their body's immune system going to do what it needs to do with respect to that flu vaccine? Or are they not going to be protected from the flu when they get exposed? So the questions that we ask really challenge the immune system to see if the immune system is doing what it's supposed to do with respect to environmental contaminants. So one of the chemicals in the lab that we study, or one of the classes of chemicals that we study, are known as per and polyfluoral alkyl substances, or PFAS. Sometimes when I do voice to text, it comes out as Pfast, and that's kind of what it sounds like. Unfortunately, Pfasts do not get eliminated from our bodies very quickly. So they're actually P slows. They stay in our body for a long time. And so we try to ask questions about what these chemicals that stay in our bodies for a long time do to the immune system. As you can see, they're pretty complicated chemicals. They're carbons with fluorines all around them. This is a really, really strong bond. So that makes them last for a long time in the environment and last for a long time in our bodies. And we're trying to find out what they do to our bodies once they're inside of our bodies. They are used in a lot of products, though, that we may come across each and every day. And if you look at the next slide, these are all of the different products that we think PFAS are used in. So if you have carpeting in your home where when you spill something on it, it wipes up right away, you probably have PFAS in your carpeting at home. If you have a couch, for example, where you spill something on it and it rolls right off, you probably have PFAS. if you eat a lot of microwave popcorn, or if you have nonstick pans, you likely have PFAS in your home. And so one of the questions is, if you have these PFAS in your home, what does that do to your health? And so we try to understand, really, do we need all of these PFAS in all of these different products? Are they really essential? Or are there other chemicals that we could use that maybe aren't quite as harmful to the environment and to our bodies? So we're trying to understand what these PFAS do in our bodies and in the environment. Here in North Carolina, we discovered a new PFAS and some other types of new PFAS in the drinking water. So we have a facility or a factory that makes these compounds, and they got released into the environment. And the questions that we have about these compounds are, well, what does it do to what do they do to our bodies when we drink them in? Excuse me, sorry. What about fish? And Dr. Gillette is going to talk about what happens to wildlife when they live in the water with these chemicals in them. So we're really asking questions about these compounds about which nobody knows anything. These are all newly discovered. There's no toxicological information. So in my laboratory, we get to ask questions about compounds that nobody has ever really asked questions about before, that nobody has ever really studied. And in my laboratory, we really work as a big team, and I have a little video that I can kind of walk you through that tells you a little bit about what we do in the lab. So this is my laboratory here at East Carolina University, and this is a day when we had a lot going on. What we are doing is grinding up spleens, and these are spleens that we took from mice, and the spleen is part of the immune system that has all sorts of cells in it that help us to understand whether or not the immune system is doing what it's supposed to be doing. So on these days, everybody in the lab, and we do actually have more girls in the lab than boys right now. This just happened to be a day where we had mostly boys in the lab. What we're doing is we're working together to ask questions about what happens to the immune system when these new PFAS are introduced into a living organism. And so you can see my lab is a very typical lab. It was built in the 1970s, so we have the nice wooden walls. But we all work together to ask questions about what happens to the immune system when these PFAS are introduced into a living organism. One of the kind of cool things about toxicology that I mentioned is that it combines policy and public health. And as a result of some of the work that I've done with PFAS, I've been invited to testify before the United States House of Representatives. So I've actually given testimony twice about the health effects of PFAS to two different subcommittees of the United States House of Representatives. I was absolutely terrified. I think the second time I did it, I was a little less terrified, but when you watch C-SPAN and you see all of the representatives sitting in a big table and the witnesses sitting in front of them, that's what I had to experience. So I have a little clip, just a minute-long clip of me giving testimony before one of the House subcommittee meetings on PFAS.
Thank you, Chairman, and thank you, members of the subcommittee, for having me here today. Yes, I'm an associate professor of pharmacology and toxicology at the Brody School of Medicine at East Carolina University, but I'm also a citizen of Eastern North Carolina. I also grew up in the state of Michigan.
Oh, let's try that again.
Maybe it got cut off a little early.
Subcommittee for having me here today. Yes, I'm an associate professor of pharmacology and toxicology at the Brody School of Medicine at East Carolina University, but I'm also a citizen of Eastern North Carolina. I also grew up in the state of Michigan.
Oh,
that's okay. I might have cut the video off a little bit earlier than what it should have been. What you should have recognized on my face was terror. I was really scared of having to give that testimony. But I grew up in a small town. I went to a rural high school. Never in a million years did I ever think that my career in toxicology would bring me to the point where I was testifying before the United States House of Representatives. And this is I think this is a really important component of toxicology. What we do in the lab has real impacts on public health and on public policy. And so if you're all interested in a career in toxicology, someday you might find yourself with that look of terror on your face as you give presentations. You know, some very well-known representatives who are often in the news. You might even get to make eye contact with one and get a little smile.
And I think I adjusted the video appropriately, Jamie. So let's take a look at that.
Okay, great.
Thank you, Chairman, and thank you, members of the subcommittee, for having me here today. Yes, I'm an associate professor of pharmacology and toxicology at the Brody School of Medicine at East Carolina University, but I'm also a citizen of Eastern North Carolina. I also grew up in the state of Michigan. I have family in the state of Michigan, so I am a concerned citizen as well. And I am more than just a dispassionate scientist who stares into test tubes. I now bear an enormous responsibility to the people in my state, my home state, and the country who are consuming water filled with PFAS. I have an overwhelming burden now, and I don't want to look into their faces anymore and say, I don't know. I want to be able to help them with my science, and I want to be able to help you to understand the science so that we can make decisions together about how to protect citizens in our country from these chemicals that are found in our water, in our food, in our air, and now in our bodies. Yes, there are over 5,000 different PFAS chemicals, but it's important to remember that they are all made to have similar functions. They are made to be stable under chemical conditions. They're made to be stable under conditions of high heat. They're made because of that carbon-fluorine bond and the strength of that bond. So they have these same functional characteristics. So they're one group or one class of chemicals that do the same things.
All right, we can probably stop it now. I have a very active face, so it's always weird when I see myself give a talk. But so when you give congressional testimony, you have 5 minutes to present your testimony. You can submit written testimony that's longer than what you present. And then when the representatives ask questions of the witnesses, they only have 5 minutes. So one of the tricks I learned from somebody from the Natural Resources Defense Council is that you should keep your testimony succinct, and you should keep your answers very short because many of the representatives want time to express their opinion as well. So that was my one little bout with having to testify before the federal government.
That's really awesome. And I'm just going to say, if toxicology doesn't work out for you, I think you could always take a role as a motivational science communicator. I'm just going to say. So now let's just check in with our interactive sites to see if they have any questions for Jamie today. So first off, let's check in with the Boys and Girls Club of Santa Clarita Valley. Do you have any questions for Jamie?
They actually are not on video, Haley, but they did send me a question for Jamie. And they are wondering, Jamie, if you had anything that really spoke to you and sparked your interest. I know you talked about the dissecting of ticks, which is pretty cool, but was there something that really pushed you to move into toxicology?
Honestly, when I worked in the health and safety office at Michigan State University, one of my jobs was to put together what's known as a chemical hygiene plan. That's sort of like the safety plan that the university has to have and that employees have to follow. And I learned about this toxicology area. And I just started putting the pieces together that toxicology blended together all these different aspects of science. And I think what was really interesting about it to me is that it was very applied. I knew that if I did work in the laboratory, which I love, that my work in the lab would be important for people making decisions about protecting public health. So that connection to the, for lack of a better term, the real world was really important to me and was something that really inspired me to dive into toxicology. And it's now one of the major reasons that I just absolutely love it and think it's the perfect science for me.
Awesome. So we can now check in with our partners at MECED. Do you have any questions for Jamie?
Yes, we do. Yes, we do.
And I think, MECED, I am going to remove the two. It looks like you're logged in 3 different times.
Yeah.
So
Yes,
I'm
we
going
are.
to go ahead and I was going to try and remove those, but I think the feedback cleared up if you want to go ahead.
All right.
Whoop, nope.
How did it feel to achieve something like that? Like being able to go to UCE?
So it was really very, very humbling. As I mentioned before, I grew up in a small town. I was the first person in my family to go to college. I think the one thing that I really wish is that my grandparents were still alive. My grandparents were really, really important to me. And if they had seen that, I think that would have just filled me with more joy than I can possibly explain. I think for me, having my family be proud of me is even more important than anything else. And so it was terrifying and humbling and just an amazing, incredible experience, but terrifying above all else.
That's awesome. And do we have any more questions from Ed? If not, I might jump in with one. So what was it? It was a particular reform or a bill that you were speaking to the House of Representatives on, or was it just testifying about the use of these chemicals?
So the first testimony that I gave in May of 2019 was for the House Committee on the Energy and the Environment, and it was a subcommittee on, I think, energy and climate change. I may have goofed that up a little bit. And they were sponsoring several bills related to PFAS in drinking water, whether or not they should have some laws about PFAS in drinking water. The second hearing from which you saw the clip was in July, and that was the House Committee on Oversight and Reform Subcommittee on the Environment. And they were actually doing an investigation into whether or not the chemical companies that make these compounds failed to report information that they had about these toxicity in a timely manner. So the testimony that I gave had scientists as well as state government officials who have been involved in the oversight of these particular compounds.
Awesome. And did anything come of that hearing? Was it, did a bill pass in the end, or was it more sort of discussion?
So the bills still have not passed from the first subcommittee, and the second subcommittee had actually an additional hearing where they invited representatives from some of the companies that produce these compounds to speak. That's a pretty interesting to watch. The name of the hearings is called The Devil We Know. And this is based on a documentary that came out last year called The Devil We Know, which is about one of these compounds known as PFOA. And there's actually a movie out right now. I have no affiliation with the film company, but there's a movie out right now called Dark Waters. Mark Ruffalo, the guy who plays the Hulk in the Avengers, plays an attorney known as Rob Bilott. Mr. Bilott was the attorney who sued the DuPont Corporation on behalf of residents of Parkersburg, the Parkersburg area of West Virginia, and obtained a class action settlement to basically turn the people into that area into a giant study on their health. And the movie is all about his experience with that lawsuit. I'm going to see it on Sunday with my husband.
That's so cool, and love Mark Ruffalo. Sorry. So do we have any final questions before we move on to our next amazing presenter? Okay, so let's hear from our other mentor, Dr. Theresa Guillette. Theresa earned her Bachelor of Science from the University of Texas. She then received her PhD in August 2017 from the Medical University of South Carolina under the direction of Dr. Lewis Gillette, Jr. and Dr. Bowden. In her PhD work, she developed novel blood-based analytical approaches to assess markers of inflammation and oxidative stress in Nile crocodiles and Mozambique tilapia. She spent 6 weeks in South Africa collecting fieldwork samples for these, which sounds amazing. She has worked with numerous non-profit organizations, such as the Kiwa Conservancy and Bald Head Island, to actively capture and release American alligators to use as sentinel species for environmental health and has created educational programs to minimize the threat of human-alligator interactions. In October 2017, she started her postdoctoral fellowship at NCSU in the Belcher Laboratory and is interested in studying how environmental contaminants, such as these Pfasts, influence the health of American alligators and fish within the Cape Fear River. Theresa, can you tell us a little bit more about how you got to where you are today?
Absolutely, and thank you for having me. So I was that kid that had a dinosaur as a teddy bear growing up. My first movie that I can remember actually was Jurassic Park, and I fell in love with dinosaurs. I was absolutely obsessed. I thought at 5 years old that I wanted to be an archaeologist, and then actually did some digging into archaeology and found out that maybe it wasn't for me. And so kind of throughout that process of trying to figure out what I wanted to do, I actually got more into music. And thankfully, I had the support of parents that were really just wanted me to be happy. And so they would push me into anything that I would get really interested in. So I actually started college as a music major. I played percussion, but also piano. But as I got into it, I kind of figured out that that maybe wasn't for me either. And so I bounced around a little bit more too, kind of like Jamie, and then thought I wanted to do pre-med. And so I actually got into a summer research experience for pre-med at the University of Texas. And there I got my first taste of life in the laboratory. I was actually studying anthrax and how specific toxins from that could actually affect different cellular pathways. As I started to get it more into that, I kind of really missed my wildlife background. I mean, I had many pets growing up and would also bring many pets home to the chagrin of my parents. And so I found myself really missing being outside. I mean, growing up as a kid, my favorite thing to do was go fishing with my dad. And so I began to really miss that. And one of my mentors told me, you know, there are a lot of great, summer opportunities for undergraduates. Why don't you go do research somewhere else? And lo and behold, I found one that fit me perfectly, where it kind of combined the laboratory side of what I was doing. So very similar to what Jamie was actually doing. But you were also the one collecting samples in the field. So there I worked at Mote Marine Laboratory for a summer and was collecting coral samples, shark. We got to do some manatee releases, and that really opened up my eyes to this possibility of kind of blending my passion and my love for wildlife into the new burgeoning like toxicology love. And so I then decided after graduation that I wanted to really go like kind of lean into that and join Lou's laboratory at the Medical University of South Carolina. So that middle picture right there is actually the first time I ever saw an alligator. It was my first week in the lab. I was a rotating student. And Lou said, well, you know what, we're going to go out into the field. Why don't we go check this out? And within 10 minutes, we saw one. Even though it was the middle of January in South Carolina, we weren't really expecting to see anything. It was kind of just a field trip. And I just fell in love immediately. I knew that that's what I wanted to do. And as I started my PhD, I really figured out that I loved blending analytical chemistry techniques with basically environmental detection in wildlife. And so kind of utilize that to start a project looking at different kind of health markers in the blood so we wouldn't have to kill an animal, to how that can relate to its health or what exposure might be telling us. So that's kind of a little bit of all over the place. But I think it's really important to know that your path throughout your career is not really a straight line. A lot of times it takes you all over the place. So I started in Texas, and then I've kind of been moving up north more and more. So then went to Florida, then South Carolina, and now I'm in Raleigh, where I am a postdoctoral researcher in Scott Belcher's lab working with understanding how these PFAS chemicals actually affect aquatic wildlife in the Cape Fear River system. So we are studying American alligators and different fish species. And what we're trying to determine is, okay, so these animals living in this environment, are they actually having any effects from the chemicals in there? And if that is that something that can be said for humans as well? Can we use these sentinel species to not only understand the health of that organism, but also our health? And so a part of my PhD research, so the cool thing about science that I always like to say is that it takes you places. You get to really go to some amazing things if you kind of stick with it and do different stuff. So, I mean, Jamie's kind of been all over the world too. But for 6 weeks, I did some field research collecting Nile crocodile samples in South Africa, in Kruger National Park, and other kind of lakes within the Mpumalanga district. And that was an incredible experience because I got to see wildlife in the wild, and I got to experience what roughing it in field work is really like. So you'll see there in the picture, that was our team. So the top one is actually my husband who works with me. That's Matthew Gillette. And then the bottom picture there is a couple of other team of scientists that we were working with, ranging from people at NASA, Kennedy Space Center, Ecological Program, to local collaborators in the South Africa province. So yeah, we can go on. So I am really fascinated by this concept of one health, one environment. So what can these top predators or even small things like bumblebees tell us about what is impacting the health of the ecosystem? So within the course of my career, I've studied everything from manatees to American alligators. I had a great white shark project going, but we weren't able to get funding for it. Still working on that. But I was actually really fascinated by these chemicals because of how similar they were to signaling molecules in the body, such as lipids. So my PhD work, I was very focused on these lipid signaling molecules and how they could tell us about the health of the organism. But the thing that fascinated me joining Scott's lab was that these perfluorinated PFAS substances, such as PFOA, are actually really similar in how they look and maybe how they act. And so this got me really interested to try and understand, okay, that similarity biologically, are there certain things that they could be doing that lipids do? And so that's kind of where I'm heading right now in my career. And then, sorry, I was trying to advance it on my screen. I'm still new at this. So here is a video of actually how our team does the research that we do in the field. So I work both in the field and laboratory. And so we capture American alligators. That's my husband there, and I'm taping the jaw shut. So it's a great exercise in trust. And so we take a quick blood sample, we do some measurements. It's really like a vet visit for these animals. And it can be as quick as this video. We've had an animal for a minute one time. And so we try to be as fast as possible because we want to minimize stress to the animal, but we catch everything from little juveniles that are about 12 inches long to big adults that are about 12 feet long, bigger than our boat. Within the Cape Fear, we've noticed that alligators seem to have these really altered body condition that we're following up on right now. So we've seen instances of not really great wound healing at this one site. And so we're kind of following that up with trying to understand. So to the right is actually a blood smear picture under the microscope. Alligators have these beautiful red blood cells. They're nucleated, and you can actually take a blood slide and understand the different components of the immune cells within that and try to get an estimation of different ratios between those immune cells and what might actually be happening. And so what we're noticing is that alligators caught within the Cape Fear site or within that Cape Fear River system actually have altered immune cells compared to ones at the Lumber River watershed. And that is associated with increased levels of perfluorinated chemicals. And so we're following this up now, but it's a kind of a alligators have an incredible immune system. They don't normally have wounds that don't heal. I've seen an alligator had its tail bit off, and then the next week come off, and he's actually fine. So they have better immune systems than we do. So if we are putting something into the environment that is affecting them, we should really be trying to understand how that's affecting us as well. And that's a big part of what the PFast network is doing right now, which I'm a part of.
So, hey, this is Jamie. I just wanted to jump in and emphasize that this is a really important piece that Dr. Gillette just presented, that Theresa just presented, that what she's doing in the field informs the lab, and what I do in the lab helps to inform her in the field. So we actually talk quite a bit about the immune system. So I work with mice, and what I see in mice has some applications to what she sees in alligators. So we talk a lot about how we can better understand the immune system of all sorts of different organisms, and then what this might help us to understand about how humans are going to be affected.
Yeah, that conservation of the immune system is key to a lot of things that we're seeing, and really like a couple of the papers that Jamie had put out early in her career and are what inspired us to kind of look at some of these things. So yeah, it has been amazing to have Jamie as a resource in the PFast network to be able to kind of like talk and collaborate, because science doesn't happen in a vacuum. You're not an island. A lot of times you're talking with other researchers, you're trying to understand how everything fits into this big puzzle of things. And so that's been absolutely incredible to do. And so we also found that high PFAS exposure in specifically striped bass, which I think are really pretty fish. My grad student doesn't think as much, but maybe that's because he got hit with one. So we found that high PFAS exposure in the Cape Fear River was kind of associated with altered immune and liver function. And what one of our new grad students, Maddie Polera, is interested and she'll be working on is how it's affecting the reproduction and survival of babies. So baby fish. So striped bass within the system have actually seen quite a big population decline, and everybody's really scratching their head about like why that is. And so we suspect that pollution might be an issue in this. And so that's a part of her graduate work now, is to basically understand that a little bit better, as well as we're going to be trying to understand that in baby alligators as well, because North Carolina does have a reproductively active population that we found, and we just want to make sure that they're healthy. Excuse me. So yeah, I'd be happy to take any questions about anything.
Perfect. So let's just jump in and see if our partner site at MECED have any questions for Dr. Gillette today.
And we're still thinking of some questions. Do you mind coming back to us? Oh, we have one? Okay, sorry, we have one.
Does the duct tape hurt the alligators, or is it safe for them?
So alligators don't have hair like we do. So if we put duct tape on us, I know I would definitely rip some off right here. But no, the way that we do it is actually really, so we'll cut it off prior to them actually being released. So we're not going to put that duct tape with them in it. Excuse me.
We still have allergy issues here in North Carolina.
Yeah, a little bit.
I've got some terrible hay fever at the moment. I'm trying to like keep it under wraps. No, so that's really cool. And is there any particular reason you chose crocodilians as sentinel species?
They were the closest dinosaurs I could actually get. No, that's actually birds. That's very wrong. Crocodilians are not dinosaurs. No, you know, when I started working in graduate school, I was really fascinated by sharks. And so I've always had a love of sharks. Great white sharks are particularly my favorite. I like them so much because I think they're always smiling, even though nobody else really has that opinion.
I agree with you. I agree.
But as I got into graduate work, I really kind of loved working with crocodilians and understanding a bit more of their basic biology, because so there's a lot of really great work done on American alligators, Nile crocodiles, salties, but there's still a lot unknown about, you know, their immune system, like how good it is, how you know, how other things within the environment could be affecting it. And so I think, you know, it's really important to have questions going forward. And so that was what led me to crocodilians, was there's a lot of unanswered questions.
It's really cool. Like even the fact that their blood cells have a nucleus is so, I had no idea, compared to human cells that don't, or human blood cells that don't have nucleus. So I thought that was really, really cool in particular, and I had no idea.
Yeah, it's really great. So you can get a blood sample and get genetic information from them. And that's, you know, unusual because sometimes in humans, you know, you can't.
That's so cool. Do we have any more questions from Mech Ed?
Okay, we have another one.
So what would you consider your job as? Like, what would you label your job as? Like a zoologist or?
That's a tough question. I like to think of myself as an ecotoxicologist, but as Jamie had mentioned, toxicology is such a multidisciplinary science. And so a lot of times what I'm doing is trying to understand the basic biology of these crocodilians, as well as like their exposure and everything. So I would consider myself a wildlife ecotoxicologist.
Any other questions? No? Okay, I think that's us. That's it for right now.
I have a question for Theresa. Theresa, have you ever been bitten by an alligator?
I have not. No, that is something that has not happened to me. Thankfully, there have been a couple of close calls. My husband was actually bit once, and that was scary enough for me. Yeah, so when we work in this field, it has its inherent dangers, but thankfully the techniques that we've been taught and have been developing for a good part of 30 or so years definitely focus on the safety of both the biologist as well as the animal.
So I actually have another comment as well. So once I started graduate school and, you know, kind of knew I was going to look at how compounds affected the brain, I started learning about other kind of famous people in toxicology. And Theresa's advisor is one of the more famous people in the world of toxicology, even though he's, I think technically was a zoologist. His so that the knowledge that he developed about the effects of environmental pollution on alligators was one of those inspirations for me to kind of look at emerging environmental contaminants, these things that we don't really know much about, to try to understand what they would do to wildlife and to human health. So she was able to work with one of the people who I regard as one of the most famous toxicologists in the world.
Yes, I was very lucky to actually do my graduate work under Gillette, and he was just a great person as well as a great scientist. And so that's what I've tried to be going forward, is a good person and a good biologist.
That's a good inspirational quote to sort of wrap up question time. So let's talk about some realities. For instance, how much can a biological ecotoxicologist or wildlife ecotoxicologist or just a toxicologist in general expect to make in terms of salary?
So it's median, right? So in grad school, you're not making that much because you're a student. You're getting your tuition paid for, but graduate programs actually do pay you. After you get that PhD, you do get a bump up in your salary, not at the private industry or even government level sometimes as in academics, but it's a range. And then you can probably expect to make between 40 to 50 as a postdoc, at least for the first 2 to 3 years, and then hopefully you'll get bumped up a little bit more after that. Assistant professorship, I know that's like low starting out, but you do have a range once you get into it. And I think Jamie can better answer that than me right now. I'm not an assistant professor.
So I can tell you my starting salary as an assistant professor here at East Carolina University was $75,000 a year. So that's where I started out, or was it 78,000? It was either 75 or 78. And once I got promoted, so I started out as an assistant professor. That's the very basic level that you start off at as a faculty member at a university. And then when I got promoted to associate professor, I got a pretty nice pay raise. My department chair went to the Board of Governors and said, we need to bring her up to a level so that she's equivalent to other associate professors. One of my good friends was a toxicologist at a private company, and her starting salary, I think she asked for $157,000. They laughed and did not give her that. So her starting salary in private industry was about $120,000 or $130,000 a year. So she made and still does make considerably more than what I make as an associate professor. But as an associate professor, I have a lot of freedoms that she didn't have in her job. She's since moved on to a different position, but there's some advantages to being a faculty member. So sometimes having a lower salary is worth having the flexibility to say what I want to say, to do events like this, or to do outside work such as expert consulting for court cases involving compounds.
Yeah, I would say that even though, academics, we don't get paid as much as say private industry, what we lack there, we gain in experiences and the freedom to really research the questions we want to do. So that's an important part.
Awesome. So here at EarthEcho, we strongly believe that we can act now for a sustainable future. Can you tell us how your careers contribute to that sustainable future?
Theresa, you can go ahead.
So what I am really passionate about and what I really want to know is, what are we putting in the environment that could be affecting our health later on? Not necessarily right now, not necessarily, acute toxicity, but what are we doing that could be affecting later generations? And I think the more that we understand that and the more that we know that, the better that we can create a sustainable future for all, not just for us.
I think for me, one of the questions that I get asked a lot from people when I go to meetings that involve the general public is, how can you live your life each day knowing what you know about all these hazardous chemicals in the environment? Aren't you scared to do anything? And if I really think about it, sometimes I get kind of scared about all the chemicals that are in our environment, and I wonder about what they're doing to my body. And so one of the things that I do personally is I try to educate myself about what I can do to reduce my exposures. So do I want to eat food that's grown with pesticides? Do I want to drink water out of plastic bottles? I'm actually drinking out of a plastic bottle now because I went to a lunch today and that's all that they had. But normally I drink out of glass or metal. Do I want to put makeup on my skin that has all sorts of chemicals in it? So I really try to educate myself and then educate my family and my friends about what sorts of products we can buy that are not going to add to my own chemical burden. And then that will help to reduce the amount of chemicals that get used, because really we as consumers, what we buy is going to have the greatest power over inspiring change so that companies start to produce products that are healthy for us and for the environment. So what you spend is probably one of the more important decisions you can make.
That's really, really awesome, Dr. DeWitt. And it kind of already answers our next question, which is, do you have any words of advice for any students out there watching this?
I would say follow what you love to do. Don't set yourself up to think that you can't do anything, because you really can. Like any dream that you have, like pursue it. Because I never would have thought that I would have been here, but thankfully I've had the support of some really great people, and yeah.
Yeah, I would add to that and say, don't turn down opportunities. I had a student in my laboratory who was working on his PhD, and a faculty member at another institution saw him give a talk at a meeting, and she said, I really want to fly you out and interview you for a postdoc. And I mean, just think about how awesome that is. Here's this really famous toxicologist saying, I want to fly you out to a different state and interview you for a position. He talked it over with his wife, and they decided, we don't want to take the chance because it's going to be really expensive where this professor lives. And he turned down her offer before he even talked to me about it. And I said, at the very least, you should have gone out there to see what the options were. So if you have opportunities presented to you that seem like something that's a little scary or something that you don't think might suit you, at least consider it. Find out more information, because you never know how that opportunity is going to change your life. If I hadn't taken the job in chemical safety, I would never have learned about toxicology, and who knows what I'd be doing now. I mean, I could be dissecting ticks for all I know, which would be fun, but over a lifetime, it might get a little bit boring. So I took the opportunity to take on a job that I thought was going to be kind of boring. It turned out to be life-changing because I didn't turn down that opportunity.
I think that's a really important point as well. Opportunities are out there, and you never know what could be behind that next door, just if you choose to say yes. So finally, before we wrap up, do we have any final questions from Mech Ed? See some looking around.
No. Oh, yes. No questions for, you have a question? 1 second. Go ahead.
Okay, so what did you like when you were in your job experience? What did you hope to gain from your job, or have you already achieved that?
So was
Did you hear her?
kind of there's some audio issues, so it kind of cut out a little bit. Can you ask that again one more time?
During like your job, did you have like any what you wanted to experience? What did you gain, or what did you hope to gain, or have you already accomplished that goal?
I know I haven't, because I'm still technically a trainee, so I'm still trying to find that end job. But within this field, I think you get to have a lot of like really great firsts. So like your first scientific paper is like just a cause for celebration, because you finally get it through and you're just like, I'm published. And your first grant. So like there's a lot of like really great little goals that you get to accomplish. And one of them for me was field work, actually. Previously to going to South Africa, I had never been out of the country before. I've never traveled out, so it was a scary and very intense experience, but absolutely amazing and life-changing. And so I think the really great aspect of this career is that you get to have a lot of those kind of goals and everything within it.
I think for me, that's a really hard question, because as I kind of said, I haven't set like specific goals for myself, and I know it's terrible. I'm reminded all the time by others that you should have a 5-year plan. You should know what you're going to do next year. And I think when I first started my job, my goal was not to lose my job, because when you come in as an assistant professor, you have only 6 years before you have to go to the next step. And if you don't make it past that next step, you get fired. And so for me, getting what's known as tenure and getting promoted from assistant professor to associate professor was a goal that I had so that I could keep my job. But now I think my goal is to never lose my passion and excitement about science. And so the day where I feel like I'm bored or I'm not having fun or I'm not inspired is the day that I should maybe consider retiring. So that's a goal that I don't want to attain. I want to keep working until they drag me out of my office because I love what I do. I love the field of toxicology, and I want to keep doing it and keep being excited about it.
That's a really, really good place to end up this presentation. Thank you to everyone for tuning in, and a massive thank you to Dr. Jamie DeWitt and Dr. Theresa Guillette for joining us today. You can keep in touch with them. Oh, sorry. You can keep in touch with them and follow them on social media. I'd also like to thank the STEMExplore partner sites and classrooms that tuned in live today, especially our interactive sites. We had some really great questions for these two lovely professors and doctors. EarthEcho has some really exciting opportunities coming up that we'd also like to let you know about. STEMExplore will continue next week as we feature women in STEM careers with our virtual career connections. We have several live events scheduled to wrap up our 2019 season, so make sure to check those out. Again, visit earthecho.org to see our entire lineup and to register. And be sure to stay connected with EarthEcho on our social media channels and our website, earthecho.org. Thank you again to our wonderful STEMExplore mentors, Jamie and Theresa, and to United Technologies for their tremendous support of this programming. On behalf of EarthEcho International, thank you for joining us and keep exploring.